Thank you for the introduction. My name is Yasuhiro Takaki from Tokyo University of Agriculture and Technology. The title of my talk is Vertical Parallax Added 360-degree three-dimensional display. Recently, the table screen 360-degree 3D displays have been developed. These are display systems developed by, Horimine, NICT, and our research group. Multiple viewers can be located at any position around the screen. Face-to-face communication is possible because table screen does not disturb the communication among viewers. These systems can be applied in various applications such as industrial design, city planning, and air traffic control. However, most of them can provide only horizontal parallax. So 3D images are distorted depending on the vertical viewing position. The volumetric displays can also generate 360-degree 3D images. This is Perspector, and these are systems developed by University of Oklahoma and Columbia University. They have vertical screens, and 3D images have full parallax. So the 3D images do not distort depending on the viewing position. However, they provide 3D images of only diffuse object because rays are diffused on the screen. So the purpose of this study is a table screen 360-degree 3D display having both horizontal and vertical parallax is developed. The 360-degree image generated on a table screen can be viewed from any direction without distortion. This slide shows the previously proposed table screen 360-degree 3D displays. They have been constructed using a high-speed projector system, a merge projection system, and a hybrid system. The high-speed projector system consists of a high-speed projector and a rotating screen. The system configuration is simple. However, the high-speed projector usually have low color and grayscale representation. The merge projection system consists of a large number of projectors and a common screen. Because ordinary projectors can be used, they have good color and grayscale representation. However, the system is large and complicated. The hybrid system combines both systems. We proposed this system at this conference in 2012. The use of multiple projectors improves the color and grayscale representation and reduces the rotation speed and increases the number of views. In this study, the hybrid system is modified to provide vertical parallax. First, I'll explain the previously proposed hybrid system. The lens shift technique is used to superimpose all images from the projectors onto the rotating screen. Because the rotating screen has a lens function, the image of the projection lens is produced on the observation space, and this image becomes a viewpoint because the image projected on the screen can be viewed from this point. Because the lens axis is shifted from the rotation axis, the screen rotation generates a number of viewpoints on a circle. The use of multiple projectors increases the number of colors and viewpoint and reduces the rotation speed. This slide shows the color 360-degree 3D display. 3 projectors were used to generate color 3D images. This is the RGB high-speed projector array. The frame rate was 22.222 kilohertz. This is the rotation screen. The screen diameter was 300 millimeters, and the rotation speed was 1,667 RPM. And this is the generated 360-degree 3D image. the number of views was 800, and the frame rate was 27.8 FPS. Now I'll explain the modified hybrid system that can provide vertical parallax. The idea is very simple, so I think you can easily imagine the idea by seeing this slide. In the previous system, viewpoints are generated on a circle at the same height, therefore only horizontal parallax is provided. In the modified system, all projectors are located at different heights, so viewpoints are generated on circles at different heights. Multiple viewpoints are aligned vertically, therefore vertical parallax is provided. In this case, the use of multiple projectors is used to provide vertical parallax. The generation of viewpoint is explained. The distance between the screen and projector is denoted by Ln. The distance between the screen and the viewpoint is denoted by Ln, and the focal length of the lens is denoted by F. This is the lens maker's formula. The lens shift amount is denoted by R, and the position of projection lens is denoted by XP and YP. The circle where the viewpoints are generated is given by this equation, and the radius of the circle is also given by this equation. Not only the height of the circle, but also the radius of the circle depends on the height of the projector. I'll explain the experimental system. In this study, multiple projectors are used to provide vertical parallax. So in order to generate color images, each projector should generate color images. DMD was used as the special light modulator. The resolution was XGA. The maximum frame rate was 22.727 kHz. The frame rate was reduced to 22.222 kHz to synchronize multiple DMDs. The projection optics was modified to allow the shift of projection lens. The LED that illuminate the DMD was replaced with an RGB LED, so the time sequential technique is used to generate color images. This is the rotating screen. The reflective lens was used. It was composed of off-axis Fresnel lens and the aluminum-coated mirror. The focal length of the Fresnel lens was 800 millimeters. Because rays pass through the Fresnel lens twice, the effective focal length was 400 millimeters. The screen diameter was 300 millimeters, and the lens shift amount was 120 millimeters. The speed of rotation was 1,481 RPM. The frame rate was 24.7 FPS. The number of views was 300 for each color. And projector arrangement and the viewpoint generation scheme are explained. The positions of the three, we used three high-speed projector to provide three viewpoints in the vertical direction. The position of the three projectors are shown in this figure. The height of the projectors were 780, 840, and 900 millimeters. The height of the circle where the viewpoints are generated were 821, 764, and 720 millimeters. The difference of the height of the circles were 57 and 44 millimeters. We measured the generation of the viewpoint, and we found that the three circles were not parallel to the rotating screen. The measured circles are shown in this figure. The three circles were inclined differently. The inclination of the circle was caused by the off-axis aberration of the Fresnel lens. Unfortunately, the vertical interval of the viewpoint was not constant and varied spatially. So the images displayed by the three projectors were rendered for the measured positions of the viewpoint. Now I show you the 3D image generated by the experimental system. These are images captured from 3 different height viewpoints. As you can see, the relative position of the plane and the buildings change depending on the vertical viewing position, so the vertical parallax was obtained. However, the problem is the color of image changed depending on the vertical viewing position. I'll show you the second 3D image. The relative position of the world changed depending on the height of the viewing point, and the color change was also observable. And the height of the shuttle was over more than 500 millimeters. So as you can see, a tall 3D object could be displayed without distortion. This is the third 3D image. The relative positions of the planet changed depending on the height of the viewing point, and 3D image did not distort depending on the viewpoint. Discussion. In the experimental system, viewpoint was generated on differently inclined circles. So the illegal vertical interval viewpoint was observed. When the vertical interval was large, regions without image were observed. When the vertical interval was small, the vertical viewing area was limited. Therefore, the inclination of circles should be reduced to provide a constant vertical interval. And a vertical diffuser with appropriate diffusion should be used to obtain continuous viewing region in the vertical direction. And the color changes in 3D images were observed because we used an off-axis Fresnel lens, and the Fresnel lens was composed of PMMA. The problem could be solved by using a reflective Fresnel lens or a low dispersion material to construct the Fresnel lens. Now I summarize my presentation. We propose a technique to provide vertical parallax for a table screen 360-degree display. An experimental system including 3DMD high-speed projector was constructed to provide 3 viewpoints in the vertical direction. The generation of vertical parallax was verified experimentally. Thank you very much.